Leibniz' concept of pre-established harmony posits that the internal states of monads unfold autonomously, yet in perfect synchrony, as if orchestrated by a divine programmer. While the idea is metaphysical, it has intriguing parallels and examples in various domains. Below are some examples that illustrate this idea of independent systems unfolding harmoniously without direct causal interaction. 1. Celestial mechanics, clockwork universe. Leibniz likened monads to clocks set in motion by a master clockmaker. This analogy can be extended to planetary orbits. The planets in the solar system move independently under the influence of gravity but follow predictable, harmonious paths dictated by universal physical laws. Gravitational waves, even though they propagate over vast distances, the waves produced by celestial events like black hole mergers are part of a harmonious cosmic structure governed by the pre-established rules of spacetime. 2. Music composition and performance. In music, independent performers can produce harmonious outputs without direct interaction. Orchestras and conductors, musicians follow a precomposed score. Each musician plays their part independently, yet the resulting performance is cohesive and harmonious due to the pre-established program of the musical score. Polyphonic music. In fugues, multiple independent melodic lines interweave harmoniously, each unfolding according to its internal logic but contributing to a unified whole. 3. Computer systems and parallel processing. Modern computing provides clear examples of systems functioning harmoniously despite operating independently. Distributed systems. In distributed computing, individual nodes or servers execute their tasks independently, yet their outputs contribute to a cohesive result, coordinated by predefined algorithms. Blockchain technology. Each node in a blockchain network operates independently, validating transactions without direct interaction. The overall ledger remains synchronized through cryptographic protocols and consensus mechanisms. 4. Genetic expression in biology. Cellular development. During embryonic development, individual cells differentiate and perform specific roles autonomously based on their genetic programming. Yet, the organism as a whole develops harmoniously, as if guided by a pre-established plan encoded in the genome. Circadian rhythms. Different organs and cells in an organism can have independent biological clocks, but they align harmoniously through genetic and biochemical regulation. 5. Autonomous vehicles and traffic systems. Self-driving cars. Autonomous vehicles navigate independently but adhere to a common set of traffic laws and communication protocols, allowing them to function in harmony without direct causation. Swarm robotics. Robots in a swarm operate based on local rules and algorithms. They act independently yet collectively achieve coordinated behaviors, such as forming patterns or optimizing routes. 6. Mathematical and geometric patterns. Fractals. Fractal patterns, like the Mandelbrot set, emerge from simple mathematical rules applied recursively. Each part unfolds independently yet contributes to a coherent overall pattern. Cellular automata. Systems like Conway's game of life evolve from local rules applied to each cell. The resulting global patterns appear harmonious, even though individual cells do not directly influence one another. 7. Social systems and economic models. Invisible hand in economics. Adam Smith's concept of the invisible hand aligns with pre-established harmony. Individual economic agents act in their self-interest, yet their independent actions often result in a coherent, functional market system. Spontaneous order. In sociology, large-scale societal behaviors emerge from individuals following simple, independent rules, like traffic patterns or crowd dynamics. 8. Quantum mechanics and entanglement. While quantum mechanics typically involves interactions, certain interpretations reflect pre-established harmony-like concepts. Entangled particles. When measured, entangled particles exhibit correlated results without direct causal interaction, as if their outcomes were prearranged. Pilot wave theory. In Bohmian mechanics, particles are guided by a non-local pilot wave, suggesting a hidden harmony governing their motions. 9. Synchronization in nature. Firefly synchronization. In certain species, fireflies flash in unison, even though their synchronization arises from individual timing mechanisms adjusted by environmental cues. Wave patterns in crowds. The Mexican wave in stadiums emerges from individual decisions to stand or sit, unfolding as a collective phenomenon without direct coordination. Conclusion. These examples reflect systems where independent entities function autonomously but align through shared rules or frameworks, resembling Leibniz's pre-established harmony. In modern physics, biology, and technology, such systems highlight the enduring relevance of this philosophical idea, providing both practical insights and a lens to explore interconnectedness in complex systems.